Today we fixed this drill that I found in the hard waste out on the street. Welcome back to the mini workbench. I was on my morning walk today and I saw this about to go to the hard waste and in one of the local streets, and it looks rather familiar because I actually have this one. This one's a Black & Decker drill, but it's actually got a problem with the switch, so I believe I've got the parts in the bottom of the box that this has actually been sitting in for a while. But this is a Black & Decker drill. This is the same drill but the 2-speed model. So the gearbox here is a 2-speed gearbox. Now I'm not sure whether this works or not. It's got the power cord cut off. A good thing about this is that it's got a really good undamaged cable, what do you call those, strain relief. They sometimes get damaged. This one's still intact on the original. Let's set that one aside just for a second and have a quick look at this. Now, first thing when we look at this, yes, there might, could be a burnt out motor. Who knows why this was thrown out? Maybe the cord was damaged and someone's just replaced it with a battery drill. All those possibilities come up, but it looks sound. First thing I had to play with was the chuck, and that's nice and free, even though there's some surface rust on that, so that's good. There's no play in that, and it feels fairly tight. Now the question is, does the gearbox work? And when I turn that seems to be uninhibited. This looks a bit odd that that's sitting like that, but that's a low speed, and I think rotate that around, and I think that's meant to be the high speed. So that's, oh yeah, that's freer. So that gearbox is working fine. I don't hear any clicking. I don't hear bad gears. I don't know why this has been thrown out. So we will work out how to get into those screws because they're a bit odd, and we'll possibly take this back panel part off and investigate what's inside. I don't want to just connect power up and, well, I'll have to undo that anyway to get to the power, but I don't want to just connect power up and assume that this is going to work. The other thing here is this switch is sticky. It's coming back slowly, and it hasn't got the detent. This one has the detent. In fact, the main reason why I saw this one is it had the switch in there. This one's got the switch missing, but it does have the detent for when you pull it back and want to lock the switch in. I had a thought about just some sort of panel over there, plastic panel over there, and a permanent momentary switch, permanently mount a momentary switch, just to get over the issue of that being damaged. But I think I do have all the parts in the bottom of that box. So this might be the start of an adventure into fixing or reinstating this 10mm 2-speed drill from, I'm not sure whether there's a date on this. I need to investigate even further, but it does say Black & Decker Proprietary Limited Australia. It does have a serial number that's a bit damaged. It's probably got more information than this one. Yeah, this one hasn't got as much information. Obviously the same vintage, same set, different option for the drive mechanism. That chuck's even freer than this one. Interesting. Okay, we're at the mini workbench having a bit of a look at this drill, and the overall condition is pretty good. The main challenge is getting into here because I need to look at the switch and also the boot. There's a screw down in there, and there are 2 screws here, and they have this triangular shape, but it's not the standard Y shape bit. It's like each side is offset. I don't know whether you can easily see that with the handheld, but what I have done is I've ground up a piece here which gives me a triangular shape on the end, and that should go in the middle of that. Okay, we've got this one loose. Let's have a look at these others. Take a slightly different approach and use the screwdriver. I'll just pop this in here. This is a restored Yankee style screwdriver. In fact, Yankee style, it is a Yankee. Get those in there, and it's going the wrong way. I don't use this because it's got nice weight to it. Oh, that's good. That's starting to come out nicely. That's exactly what we need it to do. In fact, it's a ratcheting screwdriver, so I don't need to reposition my hands. Nice and easy. One. And the second one's now coming out, so that's good, nice and easy. Now this one is loose here, so, oh yeah, nice. So there we go. What do we see inside? First impressions. A fair bit of dust around that bearing. Bearing may be worth replacing. We'll see how we go. We'll inspect that. Inspect that. Got some brushes here. We may be able to check those brushes by sliding them outwards. They will spring out when we do that. We possibly won't be able to get replacement brushes, but let's see how worn down these ones are. Oh no, there's plenty on those. You can see that in there. Plenty left on those. So let's just put that back and not disturb things. I'll just assume that the other one's the same. So this drill has not seen a dramatic amount of usage and wear, which is a good thing. Let's make sure that's settled down. I need to push that down with a screwdriver. I did have a little screwdriver here that I was halfway through restoring. I've put it down somewhere. There it is. It's over here. I just need to harden this. I've just flattened it and reshaped it. Okay, we're back again. Just having a bit of a look at this. Bit of a clean. If you do use a toothbrush for cleaning, just write on it that it's dirty, so that people don't accidentally pick it up and put it in a drawer somewhere thinking it belongs to someone. Let's have a look in here at this bearing. See if there's any wobble. Can't make that move, so that bearing looks like it's in pretty good shape. Okay. Now we've checked the brushes, we've cleaned up that bearing, that looks good. The windings are very hard to see in there, but the armature doesn't look like it's a problem. Doesn't look like any burnt windings in there at all. That's a good thing. We'll see that again from the front when we take the front off. The switch, let's recover the switch just for a moment. Now this switch is a bit sticky, and you can probably tell why. It's just got gunk all over it, so toothbrush to the rescue. Just grimy. I haven't got any electrical contact cleaner, but otherwise I would use that here and just give it a big old spray. But I wouldn't use WD-40 in this situation. Or a WD-40 as a brand does have one, but the original WD-40, yeah, that's still got a bit of reluctance to it. That looks chipped as well. I wonder if that's affecting its performance. That's probably why that ejected, because it broke out. Spring-loaded unit, so we probably won't ever get that detent fixed on this switch, but that should be a 2-speed switch. It still is pretty tight. 2-speed, 250 volts, 2 amps, line, load, nice. I don't think I can get that switch anymore, so, oh, do you reckon that might be why it stopped working? That's interesting. That's very interesting. I'm wondering now whether this was thrown out because of a simple loose wire from in there. Yeah, those wires are fastened. Where's the screw? Can't see a screw. I wonder how they're fastened. Are they just pushed in? Oh my goodness, I think they are. Yeah, I think they are. Alright, well, we'll use that concept when we recheck it, restart it. I think I will get a little bit of WD on that, so bear with me while I grab the WD. So this is not the best for electrical contact cleaning, but I'm actually cleaning the slider here rather than electrical contacts, but whoops, just a little bit on there and a little bit on this side. I'll let that soak in. I unfortunately got a bit on the bench. Work that in. That's already done the job. It's not a great lubricant for that sort of switch. Haven't got a tissue handy for wiping that down. I think that's good enough for me. So let's just put this back together. It'd be great if you could get those switches still, but they don't have those available at the moment. Many years ago they became unavailable. So it's a little bit gritty, that switch. Just slap this cover on, don't pinch any wires, particularly the white ones, which we're going to need. Oh, that's fantastic, that's freed up nicely. Awesome. Alright, well, we like that. Now, how do we test on this? We do need to come up with a plan for repowering this guy. That blue one was the one that was free, wasn't it? That might have been the whole problem. Let's hope it was, because bringing something back to life because of such a simple thing like that is something that I do enjoy. This is interesting, this cable here, now I haven't pushed down on that hard enough for that to damage that, so that's actually been caught up in manufacturing, most likely, so it's probably been like that its whole life. What is that fouling on? That could have only have been fouling on the thing there that holds the lug that holds the brushes down. It puts downward tension on there. Let's see how that lines up. You have to be careful of that. I have to come out here. That probably needs to come up as high as possible. That probably needs to be over there. The wire's pinched but doesn't look damaged, so let's see if that goes on better. There's nothing catching there. Oh, this is very encouraging. Alrighty. So let's, a couple of ways to test this, but I actually think that what I'm going to do is just wire a new cord. Yes, that'll come out of there, that's good. because that's pushed in there on the tin, I think I'm going to try and keep that. So I'll just wire in a new cord, length of cord, thread it through here. I think this rubber boot is separate to that sheath in there, so yes. So I don't think I've got anything quite as heavy as this. That's the only challenge here. I might need to put that in the vise to get that out. Okay, well, we're getting ourselves set up now for a little bit of soldering. I cut off some pieces of heat shrink and slid those on there, active and neutral. The donor cord will be this one. It's an IEC cord from a probably computer. And what does it say on here? It says 10 amps to 60 volts. Just plenty for what we're going to be using it for. Seems though the tool switch says 2 amps. Let's have a look if we can get these around this. We don't need the IEC connector, but it would be interesting to have an IEC connector on there. Don't need the barcode. The part number, is it? Yep. It's a bit goopy. We should put the strain relief on. And that's a bit loose, so we may need to put a length of heat shrink over that. Let's do that now. Alright, here we are. We've just put the heat shrink on here. I put an extra layer on, you can just see it there because it wasn't quite tight enough at that end. So I'm just pushing that on. That's good. That'll pull down tightly as we close the case. It won't be too tight, but that'll be just enough. I might put a cable tie around this section as well, just before I put it all back together. There should be, actually, interestingly, there's meant to be. So I think someone's been in here because it's missing its cable clamp. So someone has attempted to repair this before. So what are we going to learn? What are we going to understand from that? Not sure. It may mean that there's something wrong with the winding, but we won't be able to tell that until we put some power in. I don't want to pull that apart just yet. I think I prefer to just try power. If power doesn't fix it, then we'll move the next step. But everything sounds good, so we'll just do this and move on. Now I need to just pull the ends off here, and I need to get some of this cable free here, probably about that much. Trying not to snip anything underneath. No, that's good. Very take gentle nips as we move around. Prefer not to use a knife. I've seen a lot of people cut around with a knife and then just slice straight through the underlying cables. But I was taught in year 9, year 8 electrical class not to do that, but just to give a few gentle nips around the edge with the pliers, and just use the pliers to just peel that open. And then once you've got it loose, you can generally break it. Oh, there's a section that I haven't cut. Don't go deep. The other way I've seen it done is actually to pinch on the surface like this. That's the way one electrical teacher told us to do it. Alright, we're very close to getting those wires out of there. Sorry if I'm moving around a lot, but I'm just sort of exposing those wires without cutting them. And the outer insulation here is coming apart nicely. Good. Let's pull it off. It's not quite free. One more. Where is it? There it is there. Just get under there. Didn't even snip it, but let's snip that. Pull your fingernail. Is it going to work? Yep. Okay. Earth is not required. We're using double insulated. It's a double insulated tool. active and neutral, so it's wired to Australian standards. That's good. Only need a small portion of this off, maybe a bit longer than that, because we are soldering it. And about that much as well. Don't do it in your teeth, just do it with pliers. You probably should use wire strippers, but that worked out okay. I've got the soldering iron on here, so I'll just tin these. And some solder. Neaten that up a little bit. Tinning it without melting it. Tinning without melting the insulation back too far. Okay, good. Alright, that's that end. I'll put most of that over here, hang it on the vise so it doesn't fall on the floor. We've got the old pieces, we'll put that in the bin. And we just need to strip some of the end off these two in similar fashion without putting any strain on the switch, because you don't want to rip them out of the switch. Oh, that's a bit rubbery. Good. I'm hoping that heat shrink will go over these after I've joined these together. I'm just going to not butt join them, but join them side by side. See how easily this is going to work. We should be able to hold these together. Yep. Yeah, we might be challenged with the heat shrink, but we'll give it a go. Okay. Second one's often the hardest, but it looks like it's going to work for us if we line it up nicely. Nice. Yeah, maybe not so nice. Let's get a bit more solder. Run it down. Well, that's better. Feels a lot better. Alright, I'll just use these to trim the outside of the excess wire off, just so the heat shrink will go on a little bit easier. Don't cut too much off there, I'll leave that. I might need a little bit of a nip. Alright, now the black heat shrink. Yes, made it. And the red heat shrink. And will that go on? Oh, just making it a little bit further. Okay, that's in the middle. Just use the iron for these. Actually did the larger heat shrink over the stove. Right. So what we've done here, stuff the switch back in. The switch is supported by that beam, so it can't have anything on the switch, so we'll run those down there. These are now much longer, so we can do something like that with those. That's where the strain relief was. So I think it is wise to put a cable tie there. But before we do that, put the lid on so that everything lines up nicely. Yes. Okay. Nice and safe. We've got a safe tool. Alright, let's do a test. Get some power. Our new power cord. We'll run that over into the power that I've got at the back of the bench, just off camera. Now we are plugged into power now, so being very careful. Gearbox sounds, there's a bit of vibration, a bit of gear, the vibration as it slows down, but apart from that, yeah, you can just feel it, which could be a bearing. That could be a bearing. I'll open up the gearbox, we'll have a look, obviously we'll unplug it, and the next step is to deal with the mechanical, because the electrical is done. Well, I've just cut down 3 of these stainless steel 6 gauge 30mm long, though I needed to cut them down shorter to go into the existing holes. The heads I checked, they fit in the enclosures. So the next thing I need to do is just take this back off, put that cable tie on the end here just to give that extra strain relief so that doesn't pop out, and then we'll screw the back on just so that bit's completely done. Well, that cable tie was very hard to find. Must be the last one. Let's pop this off again. Just make sure that runs right up to the shoulder there. And we can tie this around here nice and tightly. Yeah, it's going to fit. Cable ties, just try and do them tightly on something this small. I'll need a plier. Should be one in this box. This one will do. Okay, I think that's got adequate bite. Let's cut that off and put that all back in here. Put the end back on. You could probably see that, I couldn't. Make sure that doesn't get pinched. Everything's seated nicely. Something's touching in there. It's not that, it's probably just this top of that cable tie. No. That. Back of that cable. Let's push that down. So it's down past that edge there. Make sure that one's down, make sure that one's in. That looks like it's all going to be fine. And, excuse me, I think it's just the boot that needs squeezing in. Oh yeah, that's much better. Right, let's put one of these new screws in with a screwdriver. Just hiding in the drawer. Next one. They're a bit rough, I didn't deburr them. So let's just put that, see if that fits together still. Yeah, that lines up. Why is that feeling like it's out of alignment? Something's ajar. Loosen this end off. Something doesn't feel right. Have we got a cable pinched? Hoping not. That feels better. Much more repairable with this type of screw. Okay. Nice. Next step, let's take the gearbox off and have a look inside there. Here we are in the front half. They're not tight. Possibly should put something down on top of the workbench to stop the grease. But hopefully the grease is solid enough to keep it self-contained. Okay, the top two are longer. Let's get a spring-loaded action in there. So let's have a look at the gearbox. Well, all I can see is old grease. There's the gear change mechanism. Suppose it goes the other way around. Well, nothing that looks too worn out there, so let's just put that back together. Well, I do just put some grease where it should be. There are no nicks out of any teeth or anything that I could see. I might come back later if I do continue to hear noises and just clean it all out and replace the grease, but at this stage I didn't think I needed to do that at this stage. Plenty of drills this age that haven't had the grease replaced, but some of the new grease I put into the gears, so some of the remaining new grease, some of the excess grease. Now just do this firm, not tight. Right, let's give it another test, then we might do some drilling. Sounds better. No reverse. It's just a drill. All right. Bad for free. 4-speed Black & Decker drill.